Hi folks, I wanted to give you this answer slide because I know quite a lot of you got a bit confused with one of the bit of theory we did in class. So we're going to look at this example which we've done already in class, and I'm just going to give you sort of 15 seconds starting from now to get the answers again. So hopefully it wasn't too difficult because it is one that you have seen before. I'm not going to spend too long going through it because you obviously can look through the PowerPoint from before. So we had 2.5 amps for I1 and I4. And the bit I want to really focus on is this bit here. We've got the motor and the bulb. So we know if there's 2.5 amps total and there's one amp going through the motor, that means there must be 1.5 amp going through the bulb. So the question I want to ask you is, which of these has a bigger resistance, the motor or the bulb? You've got 5 seconds to think about that just now. Okay, so did you get the right answer, which is that the motor has a bigger resistance, so I'm going to call it big R, and the bulb has a smaller resistance, which we're going to call little r. Okay, now, how do we know which one has a bigger resistance? Um, and the answer is, well, it goes by the current. The bigger the resistance, the smaller the current. Now, I appreciate that for some of you, if you've not done that 5 physics, that won't really make much sense. So today, well, rather tomorrow, I'll put up some notes about resistances because that's the next part we want to move on to. But it kind of follows from that phrase that I told you last time, current will always take the path of least resistance. Now, I should qualify that by saying that that doesn't mean if there's a big resistance like we have here and a small resistance, all the current will just go through the small resistance. That isn't really the case because it really depends on the difference between the resistances. If the big resistance here was really huge compared to the small resistance here, then yes, most of the current would go through the small resistor. In this case here, the two resistances aren't really that big of a difference. We're assuming that, which is why we have 1 amp here and 1.5 amp here. And that's a key thing we're going to use to analyze one of the problems that I think you find quite difficult. So here's the circuit that I think quite a few of you found a wee bit tricky. So let's look at from first principles. Is it a series or parallel circuit? Well, it's a parallel circuit. How do you know that? Because there's two ways for the current to flow through the circuit, and the two ways start here and here. So you can see you can go through I1 or I2. Now, to actually figure out which one, how much current goes through one and the other, we have to think about the bulbs. So we assume that the bulbs all have the same resistances. It doesn't tell us, so we just assume that. We know that there is one bulb here and two bulbs here. So what does that mean about the resistance here compared to here? I'll give you 5 seconds to think about that, starting from now. Okay, so what that means is that the resistance here at the top must be double. So this must be times 2 of the resistance at the bottom. Okay, now I should have mentioned earlier, what is resistance? Resistance is how difficult it is for the current to go through the circuit or a component. So that means this is twice as hard for the current to get through as the bottom bit here. So what does that mean about the current? Well, if you think about it again, current always takes the path of least resistance. So that means we are more likely to get more current going through here than we are through here. So if I was just asking you which one has a bigger current, then the answer would be the bulb at the bottom, because there's only one of them. It's easier for the current to get through. So how does that determine the way the current splits up from 0.24? Well, really, if this has got a low resistance and there's two of these, that means that it's the other way around in terms of the current. You're going to get double the current going through here compared to here. And the reason for that is because this has double the resistance, so that means it's going to have half the current compared to this bit, which has only got the single resistance. So there's lots of ways you can do this. You can do it by trial and error. You need to find a combination of numbers that has 1, and then if you double this, you can add the two together to give you 0.24. So really what we're saying is that we need to split 0.24 into two numbers. Okay, one number, so that if we multiply it by 2, we get twice the original number. Okay, and I hope that makes sense. If it doesn't make sense, please let me know. I'll try and explain it to you again. So the only combination that works, which will give you a total current of 0.24 amps, was 0.08 amps and 0.16 amps. Okay, how does that work? Well, first of all, if we multiply this by 0.2, sorry, not 0.2, by 2, we get 0.16. And if we add these two together, we get 0.24, which is the total supply current. So that way we know these are two possible answers. Final thing is, which current goes with which branch? Which one goes with I1? Which one goes with I2? So I'm going to give you 5 seconds to sort of match those up starting from now. Okay, so I2 was this one here, because remember, there's only one bulb, so it should have the bigger current. And then I1 is here, because remember, there are two bulbs compared to the one, so the current must be half the current in I2. Okay, and then obviously from there you can work out that I3 must be the same as I2, and I4 is the same as 0.24 amps, because by this point here the 0.08 has combined with the 0.16 amp. Okay, so I hope that clarifies a lot of things. As I said, if it isn't clear, please let me know and I'll go through it again with you in some other formats. Okay, so the next circuit that people found a wee bit tricky was the voltage one. Now, voltage in parallel tends to be fairly straightforward, but the tricky bit was the part that had this bit here in the circuit. So let's use our rules as before. Is the circuit series or parallel? Okay, so I'll give you 5 seconds to think about that just now. So hopefully you had the answer that the first part is that it's parallel, because you could imagine there's two ways for the current to flow. So that means that the voltage across each branch must be the same, because that's the rule for parallel circuits. So we know straight away that V3 is 1.5 volts, which I think a lot of you got. But then the tricky bit comes in this top branch here rather, which has V1 and V2. So my question for you now again is, what type of circuit is it? Give you 5 seconds to think about it starting from now. So if we think about the way current flows through this branch here, there's only really one way for it to go once it enters this branch, isn't there? So that means this bit here is actually a series circuit. So how do voltages split up in series? Well, I've kind of given you the clue. The bulbs are both identical, so they will split up evenly. So that means each bulb here must have 0.75 volts going across it. And that's because 0.75 times 2 will give you 1.5 volts. Okay, so to summarize this one, Try and identify whether it's in series and parallel, and then if there's an additional bit which doesn't fit, go through the same rules again. Is it connected in series and parallel? And then apply the rules as usual. Finally, by this point, I'm hoping, having gone through those two examples, you can now figure out how this one goes. Now, I appreciate the numbers here weren't brilliant, so I wasn't too bothered as long as you were kind of consistent with your numbers. So this one here, I'm going to assume is 2.2 amps, and this one here is 8 volts from the supply. So I'm going to give you 15 seconds to work out the answers starting from now. That's your time up. So first of all, let's do the current. So we know there's 2.2 amps going along here, because it's in series, there's only one way to flow. When it gets to this point here, is it in series or parallel? Well, how many ways are there for the current to flow? There's two, so it must be in parallel. So I'm just going to call this P. Then it goes back together to a series bit, and then we've got this identical part as before. So this is parallel, and then it goes back to series. So straight away we can tell that I5 must be 2.2 amps because that's in series and current in series remains constant. The bit in parallel, again, we're assuming the bulbs are all identical. There's only two bulbs in parallel at each part, so therefore the current must split evenly because current splits in parallel. Notice how I'm always using the same technique. Is it in series? Is it in parallel? What are the rules for series circuit? What are the rules for parallel circuits? So here, if they split evenly, that means they must be both 1.1 amp. And then the second half of the circuit is also the same. So again, it must be 1.1 amp across these two bulbs in the second part of the circuit as well. So that's the current bit. Hopefully that is now straightforward for you to understand. The voltage, again, let's think about this. So first of all, we know there's a parallel bit, and this is where it's tricky. How are these two parallel bits connected to each other? Give you 5 seconds to think about that, starting from now. So if we think about it, ignore the fact that these two bulbs are parallel to each other. In fact, that kind of helps us because remember, voltages in parallel are the same, so we don't have to worry about the individual voltages for each part. But these two bits, however, are connected in series. So if it's in series, it must mean the voltage will split up. Now, this is quite a nice thing because we've got two parts that are identical to each other. You've got two bulbs in parallel here, and you've got two bulbs in parallel here, so we can treat them as if they were identical to each other. And that means the voltage will split up evenly between these two sets of bulbs. So that means that there will be 4 volts going across these set of bulbs here, and 4 volts going across these set of bulbs here as well. So then if there's 4 volts in total and they're in parallel, that means there must be 4 volts going across this bit here as well. And then there are 4 volts going across this bit here as well. Okay, and hopefully again, you can see the reasoning, the logic behind that, and you can understand why it's 4 volts and not 8 volts as you might assume. Okay, folks? Now, to help you a little bit, because I appreciate that it can be quite tricky to visualize a lot of these rules, there is this website here, which if you click on the link, I'll provide it in a Word document for you, then you can access a simulation. I'm going to do a wee video to show you how this works and post it up separately, and you can play around with it. You can try out some of these circuits to see if it actually matches the answers that we've got, and that should hopefully allow you to sort of have a wee bit of practical, even if it's a simulation, and allow you to develop your understanding a wee bit more. As always, if you've got any questions, feel free to post on the message board and I'll try and get back to you as soon as I can.